Hello everyone, welcome to this session on how to crack VLSI jobs in 2026. You're watching this video means you really wanted to lead your career in VLSI domain. So this video is for you. Even if you are a complete fresher with no industry experience, this roadmap will guide you step by step from basics to essential skills required to enter the semiconductor industry. In 2026, the demand for VLSI engineers is growing rapidly due to the global chip shortages, the expansion of semiconductor manufacturing, and India's semiconductor mission. This presentation will help you to understand what to study, how to prepare, and what projects to do, and how to build a strong resume that gets attention from companies like Intel, Qualcomm, NVIDIA, AMD, Samsung, Synopsys, and many more. Let's begin your journey into VLSI with clarity, confidence, and a proper roadmap. Let's begin. You all know that VLSI stands for Very Large Scale Integration, where the technology used to design and manufacture modern chips which are used in mobiles, laptops, cars, AI systems, medical devices, and most of every electronic devices around us. For students and freshers, VLSI is one of the most promising career path in 2026 because the semiconductor industry is growing faster than ever. The world is facing a massive chip demand and companies are investing billions in manufacturing and design units. This will directly increase the demand for more jobs, more roles, and more opportunities, especially for the freshers who have strong fundamentals in digital electronics and basic coding skills. VLSI offers high salaries, stable growth, global opportunities, and the chance to work in cutting-edge technologies that impact the entire world. Whether you are from ECE, EEE, or even from CSE, this roadmap will show you how you can enter the VLSI domain step by step, even if you are starting from zero itself. You guys will always have the question in your mind like where to begin and how to begin, right? This is the common thing that every beginners will have in their mind. If you are a fresher starting your VLSI journey, the most important thing is knowing where to begin. Many students will get confused because VLSI has many domains like RTL, verification, physical design, DFT, analog, FPGA, and many more. But as a beginner, you don't need to worry about all these areas. You only need to start with simple fundamentals, building confidence, and then choose your domain. You don't need any advanced coding and background knowledge, just a willingness to learn step by step. As a fresher, please avoid rushing into the advanced topics like UVM or STA too early. If you master the basics and follow the structured approach, cracking a VLSI job becomes much easier for any fresher. Before you start learning for VLSI, you should know the different domains inside the industry. VLSI is not just one subject. It has a many specialized fields inside it. As a fresher, you don't need to learn all of them, but understanding them will help you to choose the right path later. Here we have the 6 major domains in VLSI. The first one is RTL design. In RTL design, you are going to write a Verilog code for the digital circuits. While writing that, you are going to convert the specifications into hardware logic. This domain is basically good for the students who like the coding and the logic design. The second domain is verification. In this domain, you are going to check for the bugs in the design where it is actually designed by the RTL designers. During this, you are going to write a test benches in SystemVerilog, where this is the highest hiring domain for freshers in the VLSI. This both RTL design and verification will come under the front-end design or verification in the VLSI industry. Where the third domain in the VLSI is physical design. This physical design is a completely back-end process where it converts the Verilog code into the chip-level layout and it works on the synthesis, placement, routing, and all those things. This physical design is a purely tool-oriented domain, and it is a core domain in the entire VLSI design. The fourth domain is DFT, which stands for the design for test. In 2026, you are going to see a lot of openings for this domain. In this domain, you are going to add the testability to the logic like scan or ATPG to check the correctness of the design. This domain will ensure the chips are tested after manufacturing. The fifth domain is analog or mixed signal. In this domain, the op-amps, PLLs, ADC or DAC will come into picture. This domain will require a strong knowledge on the circuit theory or network theory, and it requires a strong skills on the mathematics. The sixth domain is FPGA design. It is the domain where you take your Verilog code and run it on the real hardware board. Instead of just simulating the design on the computer, you actually see your logic working live on the FPGA chip. So these are all the 6 major domains that you are going to see in the VLSI design. Along with this domain, there is another domain called the analog layout design. In 2026, you are going to see a lot of openings in that domain. Now as a fresher, you do not have to learn all the domains. Just know what these domains are and you can pick one domain later in the roadmap depending on your interest. Even if you are a fresher, you must be very technically strong in order to crack the VLSI interviews. Where these are the most important topics that every fresher must start with before entering into the VLSI domain. Here I am not focusing on the advanced concepts right now, where I'm concentrating on only the strong basics that help you to become the job ready. The first topic is digital electronics, where this is the foundation of VLSI and helps you to understand how all the digital circuits will work. The second topic is basic CMOS concepts, where you just need to have a simple knowledge of PMOS, NMOS and the CMOS inverter. Next topic is Verilog HDL, which is the core skill for freshers in RTL and even for verification. After that, we have the SystemVerilog basics, which is the optional but helpful if you're planning for choosing the verification later. The next topic is C programming basics. Because right now, every VLSI companies are expecting freshers to know the basics of C, which is very helpful for scripting, debugging, and the tool interactions. For this, you don't need to have any advanced knowledge on that. If you have any knowledge on loops, arrays, pointers, and the functions are enough. And the final topic is the scripting basics. You can choose either Python or the TCL for this. So these are used for the automation and are very useful in almost all VLSI domains. Once you have learned these fundamentals, you will have a strong starting point for any VLSI career path. Now let's understand one by one what are all the things that we need to learn in each topic. Let's start with the first topic, that is digital electronics basics. Digital electronics is the first step in your VLSI roadmap because every chip in the world, whether it is a processor, GPU, memory or controller, all these things is built using the digital logic. Before learning the Verilog or SystemVerilog, you must be very comfortable with the basics of how digital circuits actually work. First, start with the core concepts which are like logic gates and Boolean algebra. This forms the building blocks of every digital design. Next, learn the combination circuits like multiplexers, adders, decoders, and encoders. These are the functional units which are used in the real chips. Then move to the sequential circuits like flip-flops, registers, counters. Because these concepts will really help in understanding how the data is stored or how the data is processed in the design. And finally, understand the timing concepts like setup time, hold time, and the propagation delay. Here you don't need the deep STA knowledge right now. Just a simple idea of how data moves in the synchronous circuit is enough. Once your digital basics are strong, you're able to understand the Verilog codes, test benches, RTL design, and the physical design much more easily. After the digital electronics, the next important topic is basics of CMOS. Don't worry, here you don't need to learn a deep analog or transistor level design logic. You just need a simple understanding of how CMOS works because every digital chip in VLSI uses a CMOS technology. First, start with the PMOS and NMOS. Learn what they are and how they behave when input is 0 or 1. Next, move with the understanding of the CMOS inverter. This CMOS inverter is just one PMOS on the top and the one NMOS on the bottom. When one turns on, the other will turn off. This idea forms the basic of all logic gates inside a chip. After this, you must know the concepts of switching, which is not the equations or any device physics, just the idea that CMOS consumes almost no static power and only uses the energy during the switching. Once you understand PMOS, NMOS and the CMOS inverter, that's enough for the CMOS knowledge for any VLSI fresher to move forward. Now let's move with the next topic, that is the Verilog HDL. After learning the digital electronics and the basics of CMOS, the next most important skill for any VLSI fresher is Verilog HDL. Verilog is the foundation of RTL design and it is also used in verification, FPGA design and even some parts in the physical design also. Now, almost all the VLSI jobs expects you to know the Verilog concepts. First, start by understanding the basic structure of a Verilog module like inputs, outputs, wires and reads. After that, learn the coding styles in the Verilog. In Verilog, we have 4 different styles. First one is the structural level, second one is gate level, third one is behavioral modeling, and the last one is data flow modeling. One of the most important thing in Verilog is the difference between the blocking and non-blocking assignments. These concepts will directly affect on how the hardware behaves. Next, learn how to write the small designs like multiplexers, counters, adders, and FSMs in Verilog. These are very common interview topics. Finally, learn the basics of writing a simple test bench so you can simulate and test your own designs. You don't need a SystemVerilog or UVM right now, just the basic Verilog test bench is enough. If your Verilog is strong, then getting into the RTL or verification roles will become much easier. Now let's move with the next topic, that is the SystemVerilog basics. SystemVerilog is the advanced version of Verilog, which is mainly used for the verification. But as a fresher, you don't need to learn the full UVM or the complex verification environments right now. You only need the basic SystemVerilog concepts that improve your understanding and help you to move into the verification later if you choose that path. First, start with the logic data types, which replaces wire and range in many cases and makes coding easier. Next, understand always COM and always FF, where this will give more predictable hardware behavior compared to the old always block. After that, learn the simple interfaces, just enough to understand how the signals are grouped and all those things. And finally, learn the very basic assertions, only for understanding purpose, not for the advanced verification. With just this basic knowledge, you will be very comfortable with the system Verilog and ready to explore the verification later when you feel confident. So this is all for the system Verilog. Let's move to the next topic, that is the C programming basics. The C programming is the another important basic skill for the VLSI freshers. You don't need to become an expert in the C or learn advanced data structures. Just simple C knowledge is enough because many VLSI tools use the C-like syntax, and debugging often requires basic logic thinking, right? First, focus on the fundamentals like variables, loops, functions, arrays, and the pointers. These concepts help you to understand the memory, data movement, and the control flow, all of which related closely to the hardware behavior. So the goal here is not to master the C, but to become comfortable with the basic coding and the logic, which will help you in Verilog, Python, and other VLSI related tools. Now let's move to the next topic, that is the scripting basics. The last important skill for a VLSI fresher is basics of scripting. You don't need to be a programming expert here, but learning a little scripting will help you to automate the task and work efficiently with VLSI tools. For this, you can go with the Python or the Tickle languages. So, Python is the easiest language that you can start with, where it is used for writing smart utilities or phrasing simulation logs or generating the test data, and even for the automatic repetitive tasks in verification and the design also. Where when you go for the Tickle is used directly inside the EDA tools. Some tools like Synopsys Design Compiler, Cadence Innovas, and Model Sim, which all supports the TCL command. Knowing basic Tickle means it is very easier to run the synthesis scripts or the simulation scripts or even the automotive tool commands also. You only need the basic things in this, like loops, variables, file handlings, and the simple functions. The small scripting skills will save you a lot of time and make you more efficient in any VLSI domain that you choose later. Okay. Till now, you know about the topics which are all needed in order to getting into the VLSI industry. The next question arises: how much time should a fresher spend on each topic? So here is an 8-week roadmap you can follow even if you are a complete beginner. Okay. In the first week, you must dedicate your all the time for the digital electronics. Just focus on the basics like gates, combination circuits, and the sequential circuits. In the second week, along with the digital concepts, understand the CMOS concepts like PMOS, NMOS, and the CMOS inverter. On the third week, spend your all the time on the various fundamentals, learn the module structures, always blocks, data types, blocking and non-blocking statements, and all those things. Fourth week, start to write the Verilog codes, the codes on the flip-flops, latches, logic gates, counters, FSMs, etc. On the fifth week, go for the system Verilog concepts. This is optional but very helpful if you choose verification later. Okay. On the sixth week, you can spend your time on the C programming. You can start with the basics and you can move with the loops, arrays, and the pointers. And in the seventh week, you go for the learning of basics of scripting, where Python or Tickle are both languages you can able to learn, or any one of the language you can learn when the basics are needed. On the 8th week, you must import the step. Now pick one domain, RTL, verification, PD, or anything, and start a mini project in that domain to build your resume. Once you finish the basics and follow the 8-week roadmap, the next step is choosing the domain that suits you. There are many domains in VLSI, but as a fresher, you should choose based on your interest, strength, and long-term goals, not based on what others says. Okay? If you have very good coding skills and logic design and building digital circuit skills, then RTL design or verification will fit for your role. If you prefer tool-based work, debugging timing issues, and working with the layouts, then physical design might be fit for your domain. If you love hands-on hardware and seeing your design run on actual chip, then FPGA design is a great choice for you. If you're good at electronics and circuits, then analog or mixed signal design may suit you. And if you like automation, testing, and quality control, then DFT is a strong and a high-paying option for you also. The main idea is don't learn all domains. Choose one domain and become good at it. Okay. Till now you have completed the basics and chosen your domain. The next step is doing the right projects. Projects are extremely important because they show the companies that you not only studied the concepts but also applied them. You don't need to go with the very big and the complex projects. Companies just want to see clean and working designs that you understand completely. If you want to move with the RTL design, then start with the simple modules like ALU, counters, mux, demux, FIFO, and the traffic light controllers. Then move to a slightly bigger designs like UART or a small CPU components. If you want to move with a verification, then write a Verilog or SystemVerilog test benches for above modules. So add random test benches and coverage and basic assertions for that. If you want to move with a physical design domain, then take a simple RTL like ALU or the counter and run it through a flow like synthesis, floor planning, placement, CTS, and routing. For FPGA, you can implement your Verilog designs on the FPGA boards and verify them with a real hardware. Okay. Whatever the domain you choose, make sure that your project is small, complete, and something you can explain clearly in the interview. Just one or two good projects are more than enough for the freshers. Now, let's talk about one of the most important thing, that is your resume. A fresher's resume should be simple, clean, and focused only on the relevant skills. You don't need a fancy template or any long paragraph. Companies want clarity, not the decoration. First, if possible, keep your resumes to only one page because the recruiters will spend hardly 20 seconds while reading your resumes. And next, list only the relevant skills like digital electronics, Verilog, SystemVerilog, and C programming, Python scripting, anything you want. But avoid adding skills you don't actually know, okay? The most important section in your resume is your projects. Add 2 to 3 projects based on your chosen domain, like RTL, verification, PD, or FPGA. Explain the objective, your role, and the results clearly. Then, please add the tools that you have used in your work. The tools like Model Sim, Vivado, Synopsys DC, or Cadence Innovals, which makes your resume stand out. If you have the GitHub link, then add that link also, because the companies will love to see the codes and project files that you have done. Finally, avoid crowding your resume with unnecessary courses, school achievements, or unrelated skills. Make it as simple as possible and professional and targeted towards only the VLSI roles. Now you have the skills, projects, and a proper resume with you. The next step is applying for the VLSI jobs. This is where many freshers get confused or feel stuck. But the truth is, getting a VLSI job is not only about knowledge, it's also about applying smartly. First, start with a LinkedIn. Search for job openings in RTL, verification, PD, DFT, or FPGA, whatever you want. Follow the companies, recruiters, and semiconductor groups. Turn on job alerts on that. The second option is applying on the company career portals. Every major companies like Intel, Qualcomm, AMD, NVIDIA, Synopsys, Cadence, etc. They post openings on their websites. Apply directly there, it has the highest success rate, okay? The third option is you can use the portals like the Naukri and Indeed to search for a job. The most important thing is building a network. Join any of the VLSI communities, Telegram groups, Discord servers, or YouTube communities. Connect with the employees and politely request for referrals in the company. Along with this, also target on the internships. Internships at startups or any training institutions increase your chances of getting a full-time offer. If you consistently apply using these methods, you will start receiving calls within a few weeks. Consistency is a key. Remember that.